Hey there, Mr. Chu here with BRAC Algebra. That's my curriculum. I'm wearing a tie and I'm going to teach you something about binomials and trinomials. So we're going to talk about factoring using the distributive property. So we're actually reversing the distributive property. So anytime you factor a GCF out of a polynomial, you have to find the biggest number of variables that you can divide both of them by. So the way that I initially would teach people to do this, when I was teaching this in middle school in pre-algebra and then in the high school algebra classes, you have to take 45x cubed and the minus 15x squared and find all of their prime factors. So the very first thing we're going to do is take the 45x cubed and divide it into everything that's a prime, and then there'll be an x times x times x, because we don't know if they're primes or not. So the way that this is usually taught, they'll teach what's called a factor tree. So I would always tell my students, divide by the smallest prime that you can divide 45 by. And that ends up being 3, and 3 times 15 is 45. Then we take the 15, and that's 3 times 5. And then it was x cubed, so we know we just have to bring an x down, times an x, times an x. And 3 times 3 times 5 times x times x times x is the prime factorization of 45x cubed. So it's 3 times 3 times 5 times x times x times x. Now we have to do that to the minus 15x squared. So we'll take our minus 15x squared, and the first thing you have to factor out is your negative 1, because it's not going to go away. Then your 15, just like up here, is 3 times 5, and then your x squared is x and x. So I write that up here, negative 15 x squared is negative 1 times 3 times 5 times x times x. So now, since we want the GCF, and GCF stands for greatest common factor. So I have to find what's common. So it has to be in both of them. And in the case like in example 2, there's 3 of them, it has to be in all 3 of them. So I circle if it's in the top and the bottom. Well, 3's in both of them. And then I circle the 5 because that's in both of them. And I circle that first x because it's in both of them. And I circle the second x because it's in both of them. So now the GCF is the product of everything that I circled. So I circled a 3, so we're going to just write 3 just one time. I circled a 5, write it just one time. I circled an x and an x. Now we simplify that. So the GCF is 15x squared. Now, this is a light bulb moment for some students. When they're struggling with this, I tell them, if you're factoring this out, we have to write our original expression down, and then we're going to write this GCF, and then in parentheses, we're going to put whatever else we have to have in order to use the distributive property to get our original. And some people struggle with that. So there's 2 ways you can do it. I can take my 45x cubed and actually divide it by 15x. That's one way to do it. But there's an easier way. What did we not circle? 3 times x. 3x. And that's supposed to be 15x squared. Sorry. That's how I saw I made a mistake. So if I take the distributive property and multiply 15 times 3, I get my 45. X squared times x, I get my x cubed. All right, now I have to go, and if you need to, you can take and write that down and divide it by 15x squared. Or you can say, what hasn't been circled? -1. There's your answer. The GCF is 15x squared, and this has been factored, and you need that for what's coming up in a couple videos from now. Okay, all right. So what happens when you've got 3? You still do it the same way. You still have to list each one and their prime factors. So I'm going to list 6a, 12b, and minus 8c, and then circle what's common. So we're going to have to take and break all of them down using factor trees. So we'll do our 6a. 2 times 3, and then just the a comes down. So that's 2 times 3 times a. The 12b now. So here's my 12b. 2 times 6. The 6 is 2 times 3 because they all have to be prime. And the b comes down. So that is 2 times 2 times 3 times b. And then the last one is my -8c. Remember, the first thing you do is your -1. Then 8 is 2 times 4. And 4 is 2 times 2. And the c comes down. So that's -1 times 2 times 2 times 2 times c. So if you would go and multiply on the right, 2 times 3 is 6 times a, yep, that's how you check it. 2 times 2 is 4 times 3 is 12b, yep. -1 times 2 is -2, times 2 is -4, times 2 is -8, times c, yep. So there they are. So you remember what you do next. You circle what's common in every one of them. It's got to be in all 3 now, and it can be a curve. That 2 is gone. So I can say that my original equals that GCF, because my GCF equals 2. So I'll go ahead and write that up here. So it'll be just like the other one. So my GCF is going to be that I circled. Now I only circled one thing, which is 2 times. And remember what I said, you can take the 6a, divide it by 2. You can take your 12b, divide it by 2. You can take your 8c, divide it by 2 to get what you have inside the parentheses here. Or you can look and see what I didn't circle, 3a. 3 times a is 3a. What I didn't circle, 2 times 3 times b, 6b. Look what I didn't circle, -1 times 2 times 2 times c, minus 4c. And yes, this is 3a. This is 6b. And this is minus 4c. And when you take and multiply it by the GCF, you have 2 equivalent expressions, and it's an equation. All right, so I've got some challenge problems for you here. Try these on your own. You could pause this right now. Try these 2 challenge problems. Challenge 1, 14y cubed plus 28y squared. Challenge 2, 4y minus 12y squared plus 16y cubed. You can pause it, try them, and then after you finish them on a piece of paper, you want to check them, there'll be a link up here you can click on. There'll be a video that I'm working those out right now, right after this, in the same time, and you can check it out and see if you did it right. This is bare algebra, factoring using the distributive property. You're actually reversing the distributive property, and we have to use that before we can factor trinomials by grouping. That's my next video. I'm Mr. Chu. I want to help you learn the algebra. Keep watching. Make sure you like my video, subscribe, and I'll see you next time.